So the starting point in a question like this is simply to find a path and try to see, can we make that path any less? And obviously there's a really bad path. We could sort of go like this and use every white square, but can we do any better? Well, I noticed that these two white squares here are adjacent to lots of black squares. So actually we can get to all of the top black squares using it. So here's a kind of a path that I could get to. Okay, and now I'm here. So I've only used two white squares so far, and it feels like I can't just get away with three. I'm gonna have to use another two. So I could use these ones with pluses in, because then I could come down and then back along. So four is possible. Can visit only. Maybe I'll do a little arrow. This is the start. I suppose it doesn't matter. I don't need an arrow. Can visit only four white squares with the root shown. When I did this originally, I was like explaining why I chose this route, which I think I would write down on the real thing. Like I just verbally said, use these white squares to access all the top ones, and I'm going to have to use what seems like I'm going to have to use two here. But now I'm explaining it. I've just drawn the route on, and hopefully, you're happy with what I've said. Can visit only four white squares with the route shown. The question is, can we use less, or is the minimum four? It feels like the minimum is four, but we have to be convincing because we're being asked to prove that our answer is indeed the smallest. Right, so let's prove that it's going to be four. And to do that, we can consider what happens if we only have three white squares. Now, the answers talk about adjacent squares to white squares and how many you can get to, and I quite like their argument. I just know I would have never have thought to do that. So I took a long time to try and piece together any kind of, sufficient explanation for this. And I feel like I've got a reasonable explanation now, alternative to the answers. So I'm just going to explain it verbally rather than writing it all down. Right, to get to this bottom right black square, I'm going to have to use one of these two white squares. So definitely I'm up to one for my count. If I'm going to get to this bottom left black square, I'm going to have to use one of these two white squares. So now I'm up to two. Have to do at least two. Let's look over here. I'm going to have to use one of these white squares to get to my third black square up here. So I'm up to three. I can't do it in one or two. I'm going to have to do it in at least three. Now, to get to this square here, number four, I'm going to have to use either this one, or this one. But if I want to get away with only using three, then I'm going to have to use this one. But unfortunately, that means I can move between them, but then I'm stuck. So after that, I'm going to have to use either this one or this one to get down, which means I'm going to have to use at least four. Okay, three is not enough because if I only use three, I have to use this one here to access three and four, if along the lines of my argument. Um, and then I just can't get anywhere from there because they're surrounded. I mean, I can go down, I should have said, but then I'm going to have to go through four, three, or this one here. Sorry, I don't think I said that before. So basically, I think I'm just going to explain this again. So I'm going to have to use one of these two. I'm going to have to use one of these two. I'm going to have to use one of these three to access square three. Now, if I also want to access square four and only use three, I'm going to have to use that circled one. But after that, I can move between here and down. I forgot about the down when I said it originally, but then I've got this like issue because I'm like stuck because I'm surrounded by these ones. So basically, I'm going to have to use a fourth one, and We know we can do it in 4 because my original diagram did it in 4, and therefore that is sufficient proof. The minimum is going to be 4. Okay, I'm pretty happy with that explanation, and I think it's good enough. All right, well done on your attempts at this problem and this challenge. Thanks.